Gradeup India's largest live learning platform. First of all, please tell me if I'm audible and visible to each one of you. First of all, kindly please let me know if I'm audible and visible. So yes, we are live with another session on models law. So basically we are going to discuss about the questions which are related to dimensional analysis, right? This models law is one of the part of the dimensional analysis. So we are going to talk about that only, right? I'll cover the entire portion of dimensional analysis. So quickly please respond if I'm audible and visible, and if I'm not, then also please tell me. Perfect. So I think everyone is here. Set. So I'll just quickly introduce myself to those students who are new to the session and who don't know me. So I'll just quickly introduce myself. So guys, my name is Joshit Singh and I have 3 years of teaching experience. I'm MTech from IIT Roorkee. My specialization of MTech is in hydraulic engineering only. GATE multiple times qualified, and area of expertise are transportation engineering, fluid mechanics, irrigation and environmental engineering. We are done with the transportation, basically highway engineering. We are done with highway engineering and now we are dealing with the fluid mechanics, right? Cool. So let's begin the session without any further delay. So hi Aman, good evening. How are you? Alright, so guys, I'll just show you the questions and you have to tell me the answer quickly. We'll just see without any further delay. So if you are ready for the session, can I have a quick heart sign in the comment box, everyone? Kindly please send me a heart sign, everybody, as soon as you are ready for the session. Hi, good evening. Srihari, how are you? Perfect. So everyone is doing fine, I guess, right? I hope you have enjoyed a lot in this Diwali season, okay, and now we can come back to these studies, come back to the original form in which we were before Diwali, right? Perfect. Alrighty then. Alright. So there is the first question. The first question of the evening is this. फटाफट से रिप्लाई करेंगे सभी लोग. एवरीबडी, विच ऑफ द फॉलोइंग, विच वन ऑफ द फॉलोइंग इज नॉट करेक्ट? यू हैव टू टेल मी विच वन ऑफ देम इज नॉट करेक्ट. विच वन ऑफ देम इज नॉट करेक्ट? एवरीबडी क्विकली टेल मी, क्विकली टेल मी. एवरीबडी नॉट करेक्ट पूछा गया है. ओके, आंसर प्लीज. सो मॉडल्स आर ऑलवेज स्मॉलर देन प्रोटोटाइप्स. Dynamic similarity between a model and a prototype can be verified by equating Reynolds number in a viscous flow. Mach number achieves significance when the velocity fluid approaches or exceeds the sonic velocity. Distorted models are always exaggerated on a vertical scale. Come on guys, you have to tell me what is the wrong option here. Out of 4 कौन सा इसमें से गलत है? बोलो. फुल पावर के साथ रिस्पॉन्स आएगा एवरीवन. सो बेसिकली मॉडल इज नथिंग, इट इज एन रेप्लिकेशन ऑफ सम स्ट्रक्चर, राइट, इन विच आई वांट टू सी व्हाट और आई वांट टू प्रिडिक्ट इट्स परफॉर्मेंस, राइट. सो द फर्स्ट थिंग इज, it is not true that you are only going to get a very smaller model of a very larger prototype. There is the example of carburetor where you have a very small prototype, and to understand the working we get a larger model. So first option is wrong. A is wrong. Everybody, A is wrong. Model are not always smaller than prototype. Sometimes prototypes are smaller than the models. Okay, so A is definitely not correct. A is definitely not correct. Clear? Clear? Everybody quickly please tell me, quickly please tell me, is it clear? Any doubt to anyone in this particular question? If you have any doubt, kindly please let me know, but if it is clear then please tell me. Perfect. Then we have consider the following statements. So you have to tell me which statement is correct here, right? So complete, this is a MSQ question. Complete similarity between model and prototype envisages geometric and dynamic similarities only. Distorted models are necessary where geometric similarity is not possible due to practical reasons. In testing of model of a ship, the surface tension forces are generally neglected. The scale effect take care of the effect of dissimilarity between model and the prototype. Answer. Everybody has to reply to this. Everybody, which one are correct? You have to tell me which options are correct out of these 4. Full power के साथ. Complete similarity between model and prototype envisages geometric dynamic similarity only. Wrong. Why? Because it should have dynamic similarity, it should have geometric similarity, and it should also have kinetic similarity, right? Similarity in the flow, you can say flow characteristics, similarity in the, you can say, geometric properties, and then similarity in the forces also in both the models, right? So A is definitely wrong. Can you just quickly let me know the answer? Everybody quickly let me know. Answer everybody. Perfect. So yes, A is obviously wrong. So yeah, next, distorted model are necessary where geometric similarity is not possible. बिल्कुल सही जवाब, बिल्कुल सही जवाब, बिल्कुल सही जवाब, बेहतरीन बेहतरीन। और आगे बताएं, आगे बताएं। In testing of model of a ship, the surface tension forces are generally neglected. Obviously, because there is no surface tension forces which we have to consider, right? So wherever you have a capillary action or wherever surface tension will come into the picture, then only you have to consider it, right? Otherwise, you don't have to consider it. And the last one is scale effect. Take care of effect of dissimilarity between the model and prototype. It is not at all like you can't say it is correct like completely. So obviously it is also wrong. So only option second and option third are correct. So 2 and 3 are correct answer. Next question. It is observed that in a flow problem that total pressure, inertia and gravity forces are important, then similarity requires that. So इनमें से you have to tell me if pressure, inertia and gravity forces are important, then which forces or which dimensionless number we are going to consider. So for that, let me tell you guys, if I talk about a Reynolds number, so in Reynolds number is the ratio of the inertia forces and the viscous forces, okay, and the viscous forces. Then comes the Froude's number, where Froude's number is nothing but it is inertia by gravitational force under root. If I talk about Euler number is inertia forces by the pressure forces, right? If I talk about the Weber number is inertia forces by surface tension forces, right? Surface tension forces. And then for Mach number, you have these elastic forces, inertia force by elastic forces. This gives you the Mach number. So basically, if you talk about pressure, inertia and gravity, so the correct answer should be, guys, which one? Euler for pressure, and obviously Froude for the gravitational and inertia. So correct answer should be Euler and Froude, which is C option. Did you get the answer? Everyone got the answer? Any doubt in this? Perfect. Very good. Let's see the next question. Very good, Ashwin. Next question is this. The Buckingham pi theorem is widely used in the dimensional analysis and expresses the resulting equation in terms of what? तो यहाँ पे दो तरह के आपके पास मेथड होते हैं. You have two method. One is Rayleigh's method and second is Buckingham pi method, right? So if you talk about the dimensional analysis, in that we have to find out that we have one thing which is a dependent variable, and it obviously depends upon some independent variable. Say for example, this x is a dependent variable and it depends upon three independent variable which are x1, x2 and x3. Right? So in Buckingham pi theorem, you have to get the value of the Buckingham pi terms. So pi terms is nothing, number of pi terms is n minus m, where n, what is n? Guys, n is nothing but n is the total number of independent as well as dependent variable. So in the example, if I talk about this example, how many total number of independent plus dependent variable I have? I have total 4, 3 independent, 1 dependent. So यहाँ पे 4 minus your dimension, जो fundamental dimensions are available. So you have 3 basically, which are m, l and t. So I'll say C is the correct answer. C is the correct answer. Next. A spillway of an irrigation project is to be supplied by means of a model constructed to a scale 1 in 9. The prototype discharges 1000 meter cube of discharge. Brilliant. That is 1000 meter cube per second. This is the discharge from the prototype. Neglect the viscous and the surface tension effect, the required flow rate for the model. So you have to tell me about the model. So guys, there is this scale ratio relation between the discharge and the, you can say, linear scale, which is given here, scale ratio. For discharge, it is QR is equals to LR raised to the power 2.5. What is QR? It is the prototype discharge by model discharge, right? And what is LR? It is LP by LM, right? And LP by LM is given to us already as 9. It is already given to us as 9, correct? Correct. So I have for prototype, I need to get it for model. So let's put all the values here, right? We are going to put the model here. We are going to put the values here. So QP, I know it is how much? It is 1000. QP is 1000. QP is 1000 and QM I want to get, and LR is how much? 9 raised to the power 2.5. How much is the answer, guys? Jatangi, the open channel flow will begin in few days. I think after 3 or 4 days I'll begin. Maybe from 24th of the November. Yes, it is already planned 24th November. Right? So please quickly tell me, guys, what is the value of this model discharge? Discharge का कितना आने वाला है? Model का discharge, how much it will come? It will be QM is equals to 1000 by 9 raised to the power 2.5. Cool. And how much that would be? 4 point. Brilliant, Vipin. Great. Good. Correct answer. That's correct answer. Great. Now, the next question. Let's talk about the next question. In similitude with gravity force, where equality of Froude number exists. So basically, they are saying the Froude model law is applicable. The velocity ratio becomes what? तो velocity ratio आपसे पूछा जा रहा है, guys. Let me tell you, if I talk about the discharge, so in discharge you have just seen that LR will be 2.5, LR की power 2.5. Similarly, for velocity ratio, LR is nothing but LR is the under root, or you can say की power 0.5 या 1/2, whatever you like to say. So this you have to remember, and most of the question in previous year have been asked from Froude's model law only. If you will see all the previous year question, you will notice that most of the questions are being asked from the Froude's model law only, right? So answer would be how much? It should be B. Perfect. Let's see the next question. A 1 in 25 scale model of a spillway. So see, if we talk about spillway, always remember it is just an example of one of the open channel flow. Cool. So Froude's model law is valid at this time. So if Froude model law is existing, then please apply this here. So the discharge in the prototype is 9000 meter cube per second. The discharge to be maintained in the model test is how much? Come on, answer. Everybody, quickly. Quickly, everybody, answer. Perfect. So same thing you have to do here again, which I have told you last time also, that you know that the discharge ratio, which is QP by QM, is LR raised to the power 2.5. We have LR value as 25 and we have the prototype discharge as 900. So the same thing we have to find out. 900 over LR is how much? LR is how much? 25 raised to the power 2.5. And how much is that? How much is that, guys? That's 0.22. बहुत ही सही. Brilliant, Praveen. 0.228 meter cube per second, or we can simply say 0.29, right? Meter cube per second. Correct answer. Very good, Shifali. Correct answer. Right? Let's move to the next question now. A ship model 1 meter long with negligible friction is tested in a towing tank at a speed of 100 centimeter per second. If the ship length is 64 meter, then the corresponding ship velocity will be. So basically now we need to get the value of the ship velocity. We have all the required values. They are saying a ship model 1 meter long with negligible friction is tested in a towing tank at a speed of 100 centimeter per second. So I have the velocity of the model as 100 centimeter per second, right? And the length of the ship is given, model is given, and the ship is given. So with the help of this, I can get the value of LR, because I know VR, that is VP over VM, is nothing but it is under root LR only. LR is your length scale ratio. So first of all, let's find out the value of length scale ratio and how much that would be. That would be the ratio of the length of the prototype divided by length of the model. So kitna hai length of the prototype? How much is the length of the prototype, guys? Quickly see. Quickly. That is nothing but, yeah, that is nothing but it is 64 is for the prototype and 1 is for this. So LR is nothing but 64 only. So let's put this value here. So VR should be how much? VR should be VP over VM equals to under root LR. Cool. So from here I can see that velocity of prototype will be how much? 100 into LR is how much? Under root 64. देखो कितना आ रहा है? And you have to convert it in meter. So divide by 100 we'll do so that it can convert into meter. So VP value is how much, guys? कितना आ रहा है VP? Under root 64 पता होगा आपको. Full power के साथ बताइए. That would be 8 meter per second. Correct answer. Brilliant. Let's see the next question. A spillway constructed to a scale 1:4 gives a discharge. Again, same question. And similarly, the question have been repeated in your previous year where they are again and again asking you the cases of spillway because Froude's model law is applicable there. So you should know that these things are very important, right? In terms of your previous year also, if you will notice. So the same story. Can you quickly tell me, guys, what should be the answer here? Everyone, let's see सबसे पहले कौन आंसर देता है. Let's see who will answer first. And yeah, there is one more thing, guys. I am beginning this midnight series from 20th of November, and this series will be on the another channel, that is our Gradeup Civil Champion YouTube channel. Gradeup Civil Champions YouTube channel, and this midnight series will be comprising of the complete traffic engineering, right? 5 classes will be there. Each class will be of 40 to 45 minutes and the timing will be 12 AM. And let me tell you guys that on Gradeup Civil Champion YouTube channel, the mode of communication is 90% Hindi and 10% English. So in case you are not aware of it, I'm already telling you. On Gradeup Civil Champion YouTube channel, there is this, you can say, because here I speak, I think 99% English and 1% Hindi. Similarly, there I speak 90% of Hindi and 10% of English. So in case you are interested, kindly join me there, right? So let's see the answer here. So the similar thing we have to do, discharge we have as 10 meter cube per second. Brilliant, right? And this discharge is of model, I suppose. Discharge from, yeah, it's a model from. Okay, so length scale ratio would be how much? 4. It is given as 1:4, so 4 is the model, you can say, scale ratio. And now the value of QP is again the same scenario. You have to find out 10 into this full power 2.5. Answer यहाँ से आप निकाल सकते हो full power के साथ, which should be 320 meter cube per second. Very good Praveen, very good Nivedita, and very good Shefali. Correct answer. Brilliant. सही है, सेट है सीन, बढ़िया. Next question. A 1:30 model of an augie spillway crest record. So this answer you have to give me. Everyone, you have exactly 1 minute to answer this and your time starts now. 1 minute है आपके पास, फटाफट से आंसर दो इसका सभी लोग. Answer can be determined, I think, in 1 or 2 seconds. So let's see if you know this or not. If not, then I'll tell you, don't worry. But first you try and give me the answer. Your time has started already and I think 20 seconds have already passed. तो फटाफट से आंसर दो फुल पावर के साथ. Let's see who will give me the answer. First पहले कौन देगा आंसर, देखते हैं. Answer everybody. Okay, so here what we have to do is 1 in 30 model of an augie spillway crest records an acceleration of 1.3 meter per second square at a certain location. The homologous value of the acceleration in the prototype. तो मतलब prototype के लिए आपसे पूछ रहा है आंसर, right? Praveen, brilliant and great, correct answer, and Vipin also correct answer. So guys, always remember the scale ratio for acceleration in Froude's model law is 1 only. So basically AP over AM is equal to 1 only. So you can say AP will always be equal to AM. Acceleration in prototype will always be equal to AM. In case you are not aware of it, let me tell you all the scale ratios so that you don't get confused anytime, right? So first of all, the velocity scale ratio is nothing but it is LR under root LR basically. Acceleration ratio is equals to 1. And the discharge ratio is equal to scale ratio raised to the power 2.5. Force, in case you have to find out, then force ratio for Froude's model law is equals to LR ki power 3, that is Q, right? In case you talk about pressure, so the pressure ka ratio is nothing but it is equal to LR only, right? Then if you talk about work, energy, torque, momentum, all these are equals to LR raised to the power 4. So in case you being asked in the examination some question directly from this, most of the question will be asked from discharge wala part, but in case they ask you from other ones also, then you should already know it. Now you don't have to waste your time in determining, inputting, you know, Froude's number for model equals to Froude's number to equal to prototype and then getting the answer. No, you don't have to do that. You can directly solve it by this. Okay, then okay, so I'll just quickly give you the information about the courses. So guys, we have these 3 courses right now going on in Gradeup Super. So first course is Gear Up, where you can improve your concepts from basics. Rank Up is for those students who want to improve their ranks, and Vision is for those students who want to prepare for ESE and GATE 2022, in which we are going to cover the complete technical and non-technical syllabus. The classes will be live only. In case you miss any live class, you can watch the recorded form of the class, and also you can watch the video later on as many times as you want. And also you can download the video in case you don't have good internet throughout, then you can download the video and watch them later on without internet also. After every class, you will get the quizzes and also the notes of the class, like the PPT which I'm going to use, and also the notes, the PDF notes you are going to get from us. And other than this, you will have a doubt section, a separate doubt section for yourself, where you will be asking the doubts and we are going to reply, right? The experts are going to reply, right? Rest, test series and all you are also going to get. So you don't have to pay separate money, a separate amount for all the courses. If you take only this subscription, Gradeup Super subscription, you can access to any of the courses. So the 6-month amount is 12,000, 12 months is just for 16,800, and for 2 years, in case you are in second year or third year, it's 24,000, right? Throughout, not per month, throughout. And also, if you need any other information related to Gradeup Super, kindly just call on this number or send an email to the help@gradeup.co in case you are shy enough to talk on a call. Then Gradeup Green Card is for those students who only want access to all the test series available on the Gradeup platform. Okay, so you just have to take the Gradeup Green Card for 1 month or for 1 year. It is up to you. It costs you around 299 or maybe 399. Just check it on the description box. Alright, so actually these are the important concepts which were there in the dimension analysis. I will suggest that please one more time, just once, go through the previous year question, and you will now won't feel any difficulty in solving any question of this particular chapter, right? And after 2-3 days, I'm going to begin the open channel flow also. Please don't miss those sessions. And again, midnight series, Gradeup Civil Champions YouTube channel, I'll be there for you. Complete traffic engineering I'm going to discuss. And then 12 p.m. I have free classes for environmental engineering, where I'll be discussing theory. So tomorrow, like on the Gradeup app, this is on the Gradeup app only, right? This is Gradeup app, Baki YouTube पर, right? So thank you so much everyone. I'll see you again, but till then you just have to do this one thing for me, and that's just take care of yourself, take care of your family, drink water regularly, as it is very important for our health and skin, and just enjoy, right? And just prep smart, stay safe, go Gradeup. Thank you so much everybody. I'll see you real soon. Till then, signing off.